Okay, so let's see if you have the algebra skills to solve this problem. And what is this problem? Well, this is a three variable linear system. And a lot of people are not going to be able to get this right because they haven't mastered how to solve a two variable linear system. Now, this type of problem is typically seen in courses like Algebra 2, College Algebra, Pre-Calculus, basically second year algebra courses and beyond. So if you are studying maybe first year algebra or pre-algebra, you may very well not have seen a problem like this yet, but stick with me anyways, because if you can solve a two variable linear system, then you will be able to understand what I'm going to be doing here. I have a lot to cover. So if you want to give this problem a try, that would be fantastic. Matter of fact, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second. Then I'm going to explain exactly how to solve a three variable linear system. This is very, very critical, especially for those of you that are in more advanced mathematics. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need assistance in learning mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so let's just go ahead and read the system. We have x, y, and z. These are the variables that we're looking for. So obviously we're looking to solve for x, y, and z. So our first equation here is x plus y minus z is equal to 0. Our second equation is 3x minus y plus 3z is equal to negative 2. And our third equation here is x plus 2y minus 3z is equal to negative 1. Now, there are different approaches you could take to solve this problem. So if you got this right, you certainly could have taken different steps. But in general, the process, there's basically a couple of main options you have to solve a problem like this, and you'll need to know all of them. I'm going to take what I think is the easiest path, but let's go ahead and take a look at the answer. Again, we're looking for the solutions, what x, y, and z are equal to. So those answers are the following. X is equal to negative 2, y is equal to 5, and z is equal to 3. Okay, so how did you do? Well, if you got this right, that is fantastic. Matter of fact, I have to give you a nice little happy face and A plus a 100%. Matter of fact, if you were in my Algebra 2 course, I might say, you know what, just take the rest of the year off. I don't know what you're doing. You're getting all these problems right. You might be watching that guy on YouTube. But anyways, in all seriousness, if you got this right, that is fantastic. And again, you could have taken a path that's different than what I'm going to be taking. But if you are totally lost, I'm going to show you basically the procedure or one easy to remember technique to solve three variable linear systems. Now, in advanced math, okay, this concept of systems is tremendously, I can't even say the word, tremendously important. And you start studying systems in like pre-algebra, algebra 1. These are two variable systems, things like x plus y is equal to 7 and 2x minus y is equal to 9. This would be an example of a two variable linear system. And the typical techniques to solve a system like this would be like the substitution method, a linear combination, or elimination method. But as you progress in mathematics, you'll see that there's different techniques that you can use to include things that deal with matrices, etc., etc. So these are linear systems, but as you get into even more advanced math, especially things like pre-calculus, you can get into things that are solving systems of non-linear equations. And that's where it just gets so much fun. A lot of students end up looking like this. Systems of non-linear equations, I don't even understand these types. Anyways, systems is a huge topic, and let's go ahead and get into it. I have a lot to cover, and I'm just going to state right up front. If you do not know how to solve a two variable linear system, then this problem is going to, be confusing. Now, if you do know how to solve a two variable linear system, then I think you'll be able to understand. Now, for those of you that are at this level of math, I'm going to direct you towards, if you really need help with this, and this is a big topic, check out my full pre-calculus course. I'm going to leave a link to it in the description. That's where you're going to get my full instruction. I get into, all advanced math at a very deep level. Okay, so let's go ahead and get into the problem. All right, so what is the objective here? Well, we have three variables, x, y, and z, and notice we have three equations. So anytime that we're dealing with systems, how many variables that we're looking to solve for, that's how many equations we have to have. In other words, if I had these two equations only, but three variables and only two equations, I couldn't find the specific actual values. I can express, the variables here, what they're equal to in general terms, but I can't find the actual value. So just remember, if you're looking to solve for three variables, you're going to need to have three unique solutions. All right, so we do have these three equations for three variables. All right, so this is what we have. So what is the strategy? Okay, so the strategy here is going to be the following. Matter of fact, let me show you here, explain it to you, then I'll get into the work. So what we're going to want to do is take this three variable system and we're going to eliminate one of the variables so we have a two variable system. Now again, for those of you that are Algebra 1 students, first year algebra, or even pre-algebra, you should know how to solve a two variable system. I already gave you an example. We're talking about basic substitution method, linear combination, or elimination method. So what we're going to do is we're going to use those same techniques, especially techniques, well, you could use either substitution or elimination, but we're going to basically take all these equations and we're going to manipulate the equations such that we end up with a two variable system. And how do we do that? Well, we're going to eliminate one variable algebraically. So let's go ahead and see what I'm talking about. So here, we're going to pick two equations, okay, out of the three, and we're going to do this twice. And the objective here is we're going to pick, again, we're going to pick two equations, and you're going to eliminate one variable. Okay, so I'm going to pick these equations right here, x plus y. Matter of fact, I'll just show you right here. I'm going to pick the first two. Now again, there's all different ways you can do this. You can pick other equations and do other steps, but this is just so easy to do right here. So you want to be looking for easy opportunities. So if I pick these first two equations, I can eliminate one variable. Now, how can I eliminate one variable? By adding. Okay, so remember, when dealing with linear systems, one of the things you're allowed to do is what they call a linear combination. In other words, if you have two equations, I can combine them and make a new equation that is perfectly, fine in terms of that system. Okay, so again, this kind of goes to your understanding of two variable systems. But effectively, what I'm going to do is just add down here. So I get x plus 3x gives me 4x. Y plus negative y is 0. Guess what? I just eliminated the y here. And I have negative z plus 3z is 2z, and 0 plus negative 2 is negative 2. So this is awesome because I just got rid of my y's, meaning I have two variables here, right? I have x and z. So I'm like, oh wow, I remember how to solve a two variable linear system. Well, I don't quite yet have a two variable linear system because I only have one equation. Okay, I need another equation, but I need another equation where we will have eliminated the y. Okay, so let's go ahead and pick another a couple of equations from this system so we can eliminate y again. Okay, so what I'm going to do here, and you can see I'm going to take the first equation, okay, and I'm going to multiply by negative 2, and I'm going to add it to this last equation. So the first two equations right here that we constructed, that would basically we got rid of the y here by adding down. What we have to do now is involve this other equation with this one that we didn't use with one of these equations to eliminate the y again. Okay, so hopefully kind of understand where I am going with this or understanding the procedure. Again, this is not a full complete lesson on it. So if you are confused, I'm going to reference you towards my pre-calculus course. I can really kind of break this down. But let's go ahead and see this now. All right, so we saw how we were easily able to eliminate y by just adding these two equations. So this time, it's not too difficult to eliminate y again. So I'm going to take negative 2 and multiply it by our first equation. So when I do that, okay, you can see the work right here. I have parentheses. Again, this should be very common to those of you that understand how to solve two variable systems. So you're allowed to multiply the entire system by whatever you want. I'm going to multiply by -2 because if I can get a -2y right here, when I add a -2y with a +2y, those y's are going to go away. But before I can do that, I got to multiply -2 by that first equation. So that gives me -2x, -2y. This is a -z, so this can be +2z, and -2 times 0 is 0. Okay, so now I'm going to use this equation. I'm going to add it to that last equation right there. So let's add down, and the whole reason I'm adding down is because I get rid of the y's again. So this is awesome. So -2x plus x is -x. The y's go away, and I have +2z minus 3z is -z. 0 plus -1 is -1. And now look what I have here. I have an equation, -x plus -z, or -x minus z is equal to -1. This is a two-variable equation with x and z. And over here, remember, I have a two-variable equation with x and z. So I can take this equation, okay, and this equation right here, combine them together into a lovely two-variable linear system. And here it is, okay? So this is the equations that we had left over when we got rid of y. And so this is a two-variable linear system. Again, stuff that you should be able to, something that you should be able to solve if you are a first-year algebra student. Okay. All right. So we have x and z, two equations. So we're going to go ahead and solve for x and z. You can use whatever method that you want. To do this, I will use the elimination method because I see these z's right here. If I can multiply, if I can get a 2z right here, I can add down. I can get rid of the z variables. Again, if you're not familiar with how to solve two variable linear systems, this will be confusing, but let's go ahead and see those steps. So I want to multiply 2 by the second equation. When I do that, I get -2x, -2z, and then 2 times -1 is -2. Now, again, this what I'm showing you here is a linear combination elimination method. Now I can add down in a column manner. So 4x plus -2x is 2x. 2z minus 2z is 0. The z's go away. That's great. -2 plus -2 is -4. So I have 2x is equal to -4. So divide both sides of the equation by 2. I get x is equal to -2. And we're like, yes, awesome. Matter of fact, we're like, all right, I'm feeling pretty good about this one. That's not, you should feel pretty good. That's a better equation. There you go. You're like, yes, I'm getting it. All right, so I got x is equal to -2. Now this is going to be easy now. So because we're going to take this answer to get our z variable. So remember, all I have to do is plug in what I just got for x, which is -2. We'll replace that x with -2 to solve for z. We could do this in any one of those equations. So 4 times -2 is -8, plus 2z is equal to -2. And let's go ahead and solve this equation for z. So we'll add 8 to both sides of the equation. So we get 2z is equal to 2z is equal to 6. Divide both sides of the equation by 2. I get z is equal to 3. And we're definitely feeling pretty good. We're like, yes, I'm getting this, because now we have x, we have z, and all we're missing is y. Okay, well, how can we get y? Well, pretty easy. All we have to do is take any one of the equations from our original system. Remember, we have x, we have z now, so we can just replace these variables with the actual solutions for x and z. Remember, whoa, I'm kind of all over the place here. Let me kind of go down here. Okay, so here's x is equal to -2. We have that, right? So just to kind of keep everything in order. And z is equal to 3. So we can replace x and z with these solutions. So we'll replace x with -2, z with 3 because these are the solution, and solve for y. So -2 plus y minus 3. When we do all this work, y is equal to 5, right? -2 plus a -3 is -5. Then move that to the other side is 5. Okay, so basically we had just solved for x, y, and z. And again, there is different approaches you could take. You could basically use the same approach. You can use the substitution method. You can use the elimination method. You could even use matrices you can use. There's different things you can do, and this can get rather complex. But this is a nice, easy approach. But what does this mean, though? What does solving a three variable linear system mean graphically? Well, this is another part of this problem that you need to understand. So let me go ahead and show you that. But first, I'm going to show you this, which is a request for you just to go ahead and not even think about it, to hit that subscribe button. I need your support. If content like this, if you're a math student and you're like, yes, Mr. YouTube Math Man, you're helping me out. Well, the best way you can help me out is just simply hit that subscribe button. And if you're going to do that, you might as well hit that notification bell so you get my latest videos as well. And as a reminder, okay, I'm going through a lot of material pretty quickly, okay? So some of you might be, discouraged. You're like, I don't understand what this guy is talking about. It just seems so overwhelming. Well, don't feel that way, okay? Definitely do not feel that way. What you need to do is just know where your starting point is, right? You just have to build up your skills. Now, some of you might already know how to solve two variable systems, but if you don't know how to solve, well, then just start right here, okay? What is a system? What are the techniques? Master that and just build up your skills. There are no shortcuts, but what you really need is detailed, comprehensive, well explained lessons and demonstrated prompts. This is the way you truly learn math. Okay, I can go through this problem in 2 minutes, but most people will be like, okay, I didn't really understand what you just did. But anyways, if you need help beyond this little tutorial, check out my full pre-calculus course. I'll teach you everything you need to know about systems and more. Okay, so let's go to talk about what this means graphically. Before I do that real quick, let me just show you real quick. If we had a two variable linear system, I'm just making something up and this may not be the actual answer. I'm just showing you here real quick. Okay, two variable linear system. Now remember, a two variable linear equation is effectively a line. Okay, this is a line. We'll call this line 1, and this would be like line 2. In other words, we could graph these lines on the x, y plane. So let me just kind of real quick draw a little x and y. And if I was to graph these lines, these respective lines like so, what I'm looking for is the intersection of these 2 points. Graphically, where these 2 lines cross, if I was to graph them, the xy point is in fact the solution. Okay, that order pair is a solution to a linear system. Now, a linear system does not have to have a solution because you can have two lines that are parallel to one another, right? So if I have two linear equations in a system and they're parallel to one another, they will never cross. So a system like this will have no solution. So there's a lot here to know, okay? But basically, what I want you to understand is that two variables is two-dimensional. Okay, in other words, well, basically, we have length and width or whatever you want. You kind of want to think about it, but you're talking about lines here. Okay, on an XY plane. Okay, so the system represents a line. Okay, and the solution is the point where those two lines cross. Okay, and of course there is a technique called the graphing technique where you just literally graph the lines in your system and then look to see where they cross. And if you can determine that point, well, you have solved the system. But what does a three variable linear system, what does that represent? You should know this. This is important. So here is our system right here. This is what we solved, and here is our answers. So instead of an xy ordered point or ordered pair, xy coordinate, that represents the solution to a two variable system, what we have here is an XYZ ordered triple. Okay, an XYZ ordered triple. So some of you might be confused about that. Well, what does that mean? Well, here it is. And this would be really the most appropriate way to describe the solution to this equation. So an ordered triple is not a point just on the XY ordered plane. What we have here, instead of the X and Y axis like this, here's X and here is Y, we have another axis called Z. So now we're talking about three-dimensional stuff here, which is awesome. So this, the solution to this system, okay, we have, again, these three variable linear systems. These are planes, okay? Effectively, this would represent a plane like kind of think of it like a piece of paper or something like, kind of going through like this, and maybe another piece of paper like that, and then they would intersect right there. So again, we are talking, more advanced math, but you need to conceptually understand what's going on here. So an ordered triple represents a point in three-dimensional space. So this particular point would be located at -2, 5, and 3. Okay, so this is also part of what you would need to understand at this level of math. But again, don't be discouraged because math is fantastic. You can do this stuff, okay? For sure you can, all right? And if you didn't get this right, don't feel bad at all, okay? Just we got to figure out where your starting point's at. But the one thing I always kind of emphasize in my videos on YouTube is that there are no shortcuts in math, and most students who struggle in math, what I have found through my decades of experience is people just don't want to put in the time. They're like, oh, let me just quickly, I don't have time to learn it. I'll learn it if I can understand it in 5 minutes. No, it's not going to work that way. Even there's just too much information. Even if you are brilliant in mathematics, it's not going to work that way. There's just too much information, too many skills. So you got to make sure you have that work ethic, that academic commitment to learn the subject. But if you have that, then you need great instruction. And that's where I want to help you out. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.